The question belongs to the mathematical induction. This is you can say that this is the second case. The first case we have already done and I uploaded the 5 video of it. This is also the question will be done in the same way. Like, for example, it is given in the question, prove by the mathematical induction that for all positive integral values of n, means it should also be done like n is equal to 1, n is equal to k, and need to prove for n is equal to k plus 1. How can we able to recognize that this question that belongs to the mathematical induction? The question format will be like this. A statement will be given and the word is written like n squared plus n is divisible by 2. Maybe another statement, I'm giving you an example for it. 5 having power n minus 2 having power n is divisible by 3. For example, 5 power n minus 1 is divisible by 4. It means that that question that will belongs to the mathematical induction second case. The procedure is simple. Again, it should be valid for n is equal to 1. Always keep in mind. It will become 1 and will be replaced by 1. 1 having power 2 plus 1 is equal to how much? 1 having power 2 is 1 plus 1. 1 plus 1 is 2. Definitely 2 is divisible by 2. So yes, it is true for n is equal to 1. Again, I'm repeating what I have done in the first step. N will be replaced by 1. See my spotlight. 1 will be replaced by 1. 1 having power 2 plus n is equal to 1. 1 power 2 is 1. 1 is already 1 plus 1 is 2. The 2 should be divisible and it is divisible by 2. It means that it is valid for or it is true for n is equal to 1. Now count for the n is equal to k. The statement is n square plus n is divisible by 2. We will suppose, second step, we will suppose for n is equal to k. We will suppose n will be replaced by k square plus k. It is divisible by 2. Now we need to prove the third one. We need to prove for the n is equal to k plus 1. We need to prove for n is equal to k plus 1. How we will do that? Again, the same trick. The mathematical statement will be replaced by k plus 1. Power 2, n will be replaced by k plus 1. The perfect square will be open. Like it will become k squared plus 2k plus 1, k plus 1. Now, write it down in this format because it is the guarantee that k squared plus k is divisible by 2. It is a guarantee. Like, for example, now we will arrange according to it. Means k squared plus k, we can write it down k squared plus k together. K squared plus k will be together because this is a guarantee. In the above statement, k squared plus k is divisible by 2. Now, what is left? We have used which one? This one and this one. Because it's a guarantee, it is divisible by 2. Now, see, 2k, 1 plus 1 is 2. Now, 2k plus 2. 2 can be common? Yes, 2 can be common. K plus 1. And we will just copy it down. Because already it is proved that it is divisible by 2. We need to prove for the k is n is equal to k plus 1. Now, as we know that it is given in the question, the whole statement is divisible by 2. Just suppose n is all positive integers. K is a positive integer. Just suppose we are taking k value is 4, for example. If we are taking the k value is 4. 4 plus 1 is 5. 5 into 2 is 10. So yes, 10 is divisible by 2. Yes, absolutely. It means that it is already a guarantee that it is divisible by 2 and it is also divisible by 2. And the key point that I can tell you, if it is a multiple of 2, it is a 100% surety it is divisible by 2. I have given this example only for your understanding. Means it is a guarantee when it is a multiple of 2. Yes, surely it is divisible by 2. It is divisible by 2, and I have also explained through example, and it was already assured it is divisible by 2. So yes, overall it is also true for n is equal to k plus 1.